Hi, my name is Sundaresh. IC engine develops power once in every 4 strokes. Combustion is required to get power. For combustion, we require fuel, oxygen and fire. Fuel contains hydrogen and carbon called hydrocarbons. Air contains oxygen, fire. During combustion, chemical reaction takes place and produces byproducts as results and called as emissions. If the combustion is complete, the emissions from the engine are harmless. But if the combustion is incomplete, then the emissions from the engine is harmful to the human and the incomplete combustion to be cured. To convert the harmful emissions into harmless, many emission control systems are used in the automobile. Now we are going to learn one of the emission control system component called Exhaust Gas Recirculation. Exhaust gas recirculation (EGR) is a process used in internal combustion engines to recirculate exhaust gases back into the engine cylinders. This process helps to reduce emissions and improve fuel economy. EGR also helps to reduce nitrogen oxide emissions by reducing the amount of unburned hydrocarbons present in the exhaust gas due to poor fuel mixing patterns within the engine cylinders. The reduction in NO emissions can lead to a 10 to 20% improvement in overall fuel economy.
At the end of this demonstration, you will be able to explain the working of exhaust gas recirculation, service EGR, tools required, trainees toolkit, equipment required, a vehicle in running condition, materials required, soft cloth. The complete combustion of fuel creates carbon dioxide, CO2, water vapor, nitrogen, inert gases. These are non-pollutant emissions, but improper air-fuel ratio and incomplete combustion pollutant emissions will come. The main automotive polluted emissions are unburned HC, hydrocarbon, CO, carbon monoxide, NOx, nitrogen oxide, particulate matter, concern with diesel vehicles. The non-pollutant emissions are CO2, carbon dioxide. The three sources of emissions on a vehicle are exhaust emissions from the tailpipe, evaporative emissions from the fuel tank, crankcase emissions from blow by gas. One of the exhaust gas emissions, NOx, can be controlled by exhaust gas recirculation. However, this can cause performance issues such as reduced idle RPM and sluggish acceleration when the engine is cold. Now, let us see how exhaust gas recirculation controls the nitrogen oxide, NOx. Scientific studies during the late 1960s discovered that NOx was a part of smog. NOx will be formed when combustion temperatures are above 1370 degrees Celsius and significantly rises during combustion above 1530 degrees Celsius. Based on the Bharat stage regulations, Indian automotive manufacturers started designing their engines for lower HC and CO emissions. But the resulting lean air fuel mixtures and higher engine operating temperatures increased NOx formation in the exhaust. To lower NOx formation, add the small amount of exhaust gas into the intake manifold. Because the exhaust gas will not burn, it does not contribute to emissions at the tailpipe. So, NOx will also reduce. This re-entered exhaust gas is depleted with oxygen content in the intake air and diluted mixture burns slower in the combustion chamber. Hence, it reduces the combustion chamber temperature and NOx emissions. The exhaust gas recirculation, called EGR, allows a small amount of exhaust gas. Small amount means less than 10% of the total gas to be routed into the incoming air-fuel mixture. This results in diluting the air and fuel mixture and lowers the combustion temperatures by 150 degrees Celsius. That's why NOx will not be formed. EGR valve consists of a spring-loaded diaphragm and a tapered pintle which opens and closes the port. Normally, the pintle is in closed position, and when the diaphragm lifts, the tapered pintle opens the port. Opened port allows small amount of exhaust gases into the intake manifold, and it mixes with the fresh air in case of diesel engine or air-fuel mixture in case of petrol engine. Closed port is when the exhaust gases cannot pass through it because it is closed by a valve. The EGR operates mechanically or electrically. EGR valve is closed during idle and cold because very little NOx is formed at idle or when the engine is cold. EGR opens when the engine accelerates under load or during part throttle opening. EGR operates mechanically by vacuum. When the throttle valve opens, the vacuum above the throttle will increase and EGR opens. Nowadays, computer-controlled EGR uses a solenoid and mass airflow sensor. Mass airflow sensor gives information on airflow. Based on that, the engine control unit operates the vacuum valve which controls the EGR. Solenoid. When EGR is required to lower NOx emissions, the ECM energizes the vacuum valve. It has two hoses, that is, to EGR valve and intake manifold. An electrical connector is provided to energize solenoid. Working of EGR circuit. ECM energizes vacuum valve when required to lower NOx. Solenoid opens and supplies vacuum to EGR valve. EGR valve opens and allows a specific amount of exhaust gas to recirculate into the intake manifold. This exhaust gases is depleted with oxygen, does not allow burn in combustion chamber, thereby reducing combustion chamber temperature and NOx emissions. To precise the exhaust flow, an orifice is provided. It creates a pressure drop. Small pipe connects between orifice and EGR valve to pressure feedback sensor. Sensor sends a voltage signal to the ECM in relation to the amount of exhaust flow through the EGR system and demanded by the ECM does not matches and makes correction in EGR flow. Conditions of EGR valve opening. ECM does not open the EGR valve under certain conditions. When the engine coolant is cold, no NOx emissions. When the engine is idle, maybe rough idle. When the throttle is wide open, reduces engine power. ECM opens the EGR valve under certain conditions. The engine is operating at normal temperature. Speeds above approximately 50 km per hour. EGR system diagnosis. In case of vacuum-operated EGR, then disconnect vacuum hose from EGR. Connect vacuum hand pump. Run engine at idle. Apply 20 in HG vacuum by hand pump. Observe engine speed reduces to 100 rpm or maybe stall. Then EGR is OK. Or otherwise inspect the system. Similarly, electrically operated EGR can be checked with multimeter. Take a multimeter and as per the manufacturer's recommendation, check the resistance values in the EGR solenoid. Suppose if the obtained value is not matched with the manufacturer's specification, then replace the vacuum valve. Effects of poor EGR system. Check the engine malfunction indicator. If it shows, then problem may be with the EGR. Poor engine performance means poor mileage may be due to poor EGR. If you feel fuel smell from the tailpipe, maybe the reason is EGR due to more fuel entering engine and unburned fuel coming out from the engine. If EGR is open with the engine idling, engine idle is rough and engine may stall. When the EGR is not open under any condition, NOx emissions are high and engine detonation may occur. Detonation or knock would likely result in reduced fuel economy. EGR system maintenance. Inspect all the vacuum hoses for cracks, deterioration and damage. Be sure hoses are properly connected. Inspect the wires of solenoid, sensor. Inspect the small exhaust pipe from the exhaust manifold to the sensor for leaks.
Thus, we have learned about the EGR system in the vehicle. The EGR system reduces NOx pollution, or otherwise, the formation of NOx spoils the atmospheric air and leads to knocking. Two types of EGRs are available. One is vacuum operated and the other one is electrical operated. Check EGR connections during the periodic maintenance. If EGR has any problem, check for indicator lights and follow the manufacturer's procedure for finding out the faults. Hope you have clear on this. Do this exercise with the help of your instructor.